This is the second worksheet that you should have in front of you. It's on the third page. Okay. Continuing what we learned from the last video, calculating the concentration of strong acid and strong bases here, and then determine the pH. You will continue doing that on this page. Okay. So first of all, calculate the following. Always just start by determining if the acid is strong or weak. So the way to do that is that list right here. It's very limited number of strong acids and weak and strong bases. The rest are going to be considered weak, and they're weak because of this thing called a equilibrium constant here, dissociation constant. Okay, if the dissociation constant is a big number, it's a high number, it is a strong acid. Sulfuric acid here says a strong acid, dissociation is very high. The weak acids, these will come into play because not all of it will split up completely. Okay, they only partially, and they go reverse as well. And then your bases, not so much here. There's a couple. Ammonia is the most common one. NH3 that we use here. The constant is Kb here is 1.8 times 10 to the negative 5. Okay, the Ka, what Ka is a constant. It is the product of the ion, which is the H plus ion, and the whatever the other part is over the original acid. This is the original acid down here. It's labeled as Ha, and hydrogen ion, and the other part, the anion part of the acid, is that. So the product of those two equals this number. So for, let's just pick a random acid up here. Carbonic acid, 4.3 times 10 to the negative 7. So 4.3 times 10 to the negative 7 equals, the two things that carbonic acid splits up is what? H2CO3. Okay? The two things that splits up to is, so the concentration of H2CO3 goes down here, the concentration. And then the other two is H plus, and then you have CO3 2 minus. Okay? So that's kind of the idea there, how much they split up, and you add the products. These are all going to be numbers for you. Okay? We'll do a couple examples here. Let's find one that's a weak acid. HCl is strong. Number 1. BaOH2 is a strong base. Strong acid, strong base. KOH, strong base. HI, strong acid. Number 5, strong acid. Number 6, strong base. Number 7. Oh, okay. I see what they did here. They gave us the Ka, so we don't even need to look up Ka. So these are all going to be weak, 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 and weak. Okay. So we'll start from the top. Instead of just jumping to the weak, we'll start on the top. Okay. What's the pH of 0.004569 molar HCl? This is a strong acid. Remember, HCl will split up into H plus and Cl minus. Okay, H plus and Cl minus, and we have a concentration of 0.004569. So it'll give us, so basically if we have one HCl, we have one H, right? If we have one HCl, we have one Cl, correct? So the concentration of HCl is exactly the same concentration as H and Cl, 0.004569. And really that's all we're looking for, the concentration of H. That's what we're concerned about. So we don't really care about the HCl, but it's going to be the same thing. Molar. They're all molar. Okay? And so to find the pH, we take the negative log of that. Negative log of 0.004569. And then punch that in your calculator. Negative log, control log, 0.004569. Dang it. That's the base. Don't do that. 0.004569. Enter, and my pH is 2.34. There you go. Pretty simple there. Okay. Notice most of these H hydrogens are only 1, so they also should be very simple. Whatever the concentration of the acid is, that is the concentration of H plus. For barium hydroxide, though, this is a little different here. BaOH2 will split up into one Ba 2 plus, plus 2OH minus. Okay, sorry. There you go. Take a minute, copy it. Alright. So we have a 0.000234 molar concentration. 1 Ba, so that's exactly the same thing, 0.000234 molar. But you have 2 OHs, so you have to double that. Remember, 1 BaOH will give you 2 OHs, so it doubles. So you have to double that, so it's 0.00235. You get 4.3708. I think that's, let me plunge that in. 0.00235 4 times 2. 0.0047. Oh wait, oh, I'm missing a 0. There it is. Okay, be very careful with that. You miss 1 0, it changes quite a bit. And then, so that's my OH concentration. So this is OH concentration. Right? So if I want to find pH, what do I need to do? I need to find the POH, right? So POH is negative log of that. POH is negative log of 0.000478. Oh my. Negative log. Negative log. Dang it, no. Negative log. Skip that bottom, 0.004708. Enter. I get 2.33. That's really close to the one above. Is that right? Dang it. Again, I missed a number. I missed a 0. There you go. There's a common mistake. Negative log. I have to do that again. 0.0030. 4708. 3.32. 3.32. That's my POH. So how do I get the pH? pH equals 14 minus 3.32. And that'll give you 14 minus 3.32. Calculator here. I get 10.68. 10.68. That is my pH right there. Okay. A lot of numbers here. So if you don't follow this video from earlier, from the top part, from the beginning, you're not going to understand if you're just staring at this number. So make sure you pay attention, because I do float around from here and there quite a bit. All right. So that is your strong acid bases. They dissociate completely. And notice the rest are just all ones. 1OH, 1H, 1H, 1OH. So whatever the concentration is the same concentration on the other side. Okay? So this one. Number 7, the weak acid and weak bases are a little different because they have this Ka part. All right? So for these, you have to do this thing called the ICE table. ICE. Okay? I is initial. C is the change. E is the equilibrium. Equilibrium is when they're constant, when they're stable. Okay? And so you have this original concentration, which is the Ka, the Ha, and then the H plus, and you have the last part is, so this ice table looks like that. And the last part is the ion, whichever the A minus is. Okay? pH of HF. So HF works like this. HF, note it's a weak acid, so it goes to H plus and F minus. So it's H plus. This A minus is actually F minus. Okay? So the concentration we have is 0.34 molar. It's going to split up into an X amount because we don't know how much will split up. Okay? Because initially we have 0.34 molar of that. When we start, do we have any H plus and F plus? It's going to be 0 and 0. Okay? It's always 0 when we start. So initial is always going to be 0, 0 for the first one. The change, we don't know. It's very small, so we don't know. The change of this, HA is going to subtract by X. Okay? And H plus is we're going to add by X. We don't know how much. So in math and anything, if we don't know, we give it a variable, and this variable is X. Okay? And so now we take this equilibrium, you add up those two columns, add them up. 0.34 minus X. This is X, this is X. F equals X, H equals X. Okay? because this X number is going to be so small, ladies and gentlemen. This number is going to be so small. This thing is so close to 0. The H plus, it matters. Close to 0. Remember, all the concentration of H plus is always going to be really, really, really tiny. So this is significant. This is significant, but this 0 here is insignificant. For example, if you have 34 cents and you take a 0.0000000 penny off, does it really change it that much? Not really. So this 0.34 is going to be just 0.34. You throw away that X because it's really so small that's insignificant. Usually they say 5%, but then we can disregard that for our purpose here. And so the Ka, as I mentioned earlier, Ka equals the product, which is H plus times the F minus, all over the original, which is the HA. And so we plug that into this equation, X over, so we have the Ka, which is 6.8 times 10 to the negative 4 equals the concentration of H is X times X over 0.34. Okay? So we follow that. We take this and we plug into that equation. We take these three things, we plug into that equation. H go there, use a different color. It's probably wiser. H go there, F go there, 0.34 goes there. The Ka we get from the formula here. If they don't give us the Ka, then we have to find it on the chart here. Some acids, for example, if they tell us hydroazoic acid, then we have to find it there. Okay. So now we just have to solve for X, because X is our H plus. And once we have X, we can find the pH. Okay. So basically this is X squared. I'm going to use a new sheet here. And copy that over, okay? 6.8 times 10 to the negative 4 equals X squared over 0.34. Okay? Let's use some algebra here to find X squared. Cross multiply. So 6.8. I'm going to use the EE button because it's faster. Not really. Not when you mess up. 6.8 e to the negative 4 times 0.34. So I get 0.0, so you can write that down. 0.123231 equals X squared. Okay? And so how do I get X by itself? In algebra, we would take the square root of both sides. So take the square root, control square root here, control answer, hit enter. So the concentration, X is equal to 0.0152. So X is 0.0152. Going back to our little table here. What is X? X is the H plus concentration. So now H plus is 0.0152. And now you can find the pH. pH is equal to negative log of 0.0152. And take the negative log of that. Negative log. And you get 1.81. 1.81 is the pH. Going back at that, you just make this table. Essentially, what it is going to be, it's going to be X, X, and whatever that value is. So for simplicity, for our purpose, it's going to end up, whatever the Ka is, is equal to X squared over the original concentration. Okay, so whatever X squared is over the original concentration, and you solve for X, and X in that case is going to be your Ka and your H plus. Okay, and so we get to number 11. You could turn to number 11 real quick. Never mind, the time limit for this video is over, so next video.